Today let's talk about summing amplifier or adder. Operational amplifier can be used for different types of operations like addition, subtraction, multiplication, division, integrations, logarithm, etc. So here we are going to talk about how operational amplifier can be used as a adder or summing amplifier. This is the operational amplifier, and in this we have a negative input and a positive input, that is inverting and non-inverting interval inputs. Here V1 and V2 and V3 and so on, Vn are n different inputs applied across resistances R1, R2 and so on Rn. So the current because of these sources at this point we say I, and this can be easily calculated by using simple Ohm's law. V is equal to IR, so I is equal to V1 upon R1, V2 plus upon R2 plus and so on, plus Vn over Rn. Now the output of an operational amplifier is taken from that of the feedback resistance, which here is R dash. So the voltage drop across this resistance R dash is I R dash, and I we have calculated this one, so then we can write V output is equal to minus I R dash, and using the value of I we have this expression. Now if suppose R1, R2 and so on, all the input resistance are same, then your output can be expressed as like this, where V out is sum of or is proportional to the sum of input voltage values. Next we are going to talk about the differential operational amplifier. In this case the output is proportional to the difference of the input signal, and in the diagram we can see that V1 and V2 are applied across inverting and non-inverting terminal respectively, and here we have a bridge kind of situation where we have four different resistances R1, R2, R3 and R4, and if it's like in balanced state R2 upon R1 is equal to R4 upon R3, then the input across these inverting and non-inverting terminal will be equal to the difference of V2 and V1, and the current which passes through R2 will be V2 minus V1 upon R1, and hence the voltage drop across resistance R2 will be V2 minus V1 upon R1 into R2.